today's lesson, we are going to learn about differential equations. So what is a differential equation? It is an equation that consists of a derivative. And how do we identify the order of a differential equation? We identify it by the derivative that is occurring within that differential equation. So on equation number 1 here, we have dy dx. That is the first derivative. It shows us that the order of this equation is first order. And then on the second equation, we have d squared y, and that is the second derivative. It shows us that this is a second order differential equation. So, okay, there is a lot of theory that is involved in differential equations. We don't want to spend so much time on that. So we are going to look at examples of how we can be given problems in these differential equations. So let's look at example number 1. Example number 1 says show that the function y is a solution to the accompanying differential equation. So the function is this one here, and then this is our differential equation. So how do we show that this function is a solution to this differential equation? We have to differentiate our function. So if our function is y equals to e to the power negative x, when we differentiate this, we will say dy dx is equal to negative e to the power negative x. So when we want to find that this is a solution to that differential equation, we need to go and substitute into our differential equation. So our differential equation is 2 dy dx plus 3y equals e to the power negative x. So we will substitute what the value of dy dx we found, and we found that this is this value here. And then we will replace y with this value here, and then we will equate to this. So if the left hand side is equal to the right hand side, we will definitely say that the function y is a solution to the differential equation. So we can see here we'll have negative 2e to the power negative x, then plus 3 to the power negative e to the power negative x, then e to the power negative x. Then when we add negative 2 and plus 3, we get that this is equal to e to the power negative x. So we can see that the left side of the equation is equal to the right side of the equation. So that function y, it's actually a solution to that differential equation. So if maybe we differentiated and when we plug back into the differential equation, we find that left hand side is not equal to the right hand side, it was not going to be a solution. So, or maybe we'll go back and check if we have differentiated it correctly. So let's continue. So we have types of differential equation. So we will look at differential equations of which we can be able to separate variables of x and y. Let's use x and y for this lesson. So if you are having an equation of dy dx, generally we have function here g of x and h of y. So if we want to separate this, we want to make sure that h of y is attached to the dy. So if we divide by h of y, we'll have it this side, h of dy over h of y, and we multiply by dx, we'll have g of x and dx. So we were able to separate. So this type of equation, we call it's a separable variable. And then we can integrate this now. Then when we integrate, we can write that constant of integration. So this is a general form, and then the value of this, we can now just say it's a big H of y to show that now we have integrated, and then this now is g of x. So this is just a general equation for the separable variables. So okay, here we could choose to put the plus c on the side of y, but we chose it to be on that side of x. So it's up to you, but mostly we'll advise you to just put the plus c constant on the side of x. So we'll look at an example. So if we have example 2, for example, if we have dy dx, this is a very, very simple differential equation because it only has 2x. It doesn't even have y variables. So how can we solve this one now? We will separate. Here we have dy dx. We'll take dx to the right hand side. Then we will have dy is equal to 2x dx. Then if we integrate, we put the integral signs. Then when we integrate y, we find that it's going to give us y. When we integrate 2x, it's going to be x squared plus c. So we have found this is a general solution because we still have a constant here. We are not given the values of x and y in order to find the constant. So this is a general solution. So let's look at another problem. So here's another problem. If we have d square y dx squared equals to cos 3x. So we can see that this is a second order differential equation because we have d square y over dx squared. That is the second derivative. So if we want to find a general solution in this, our general solution mostly, it has to be y in terms of x at the end. So how can we do that? Firstly, we will need to separate the variables. So I have d square y, I will multiply by dx squared cos 3x dx. So if I integrate here now, I will find that when I integrate d square y, only dy will be left. When I integrate cos 3x, we know that when we integrate a cos, it's not going to give us a negative, but it's going to give us sine 3x. We have to divide by 3 because we have cos 3x. Then plus a constant. So here it's d square. So it means that if I've integrated once, I'm left with dx only. So if I integrate again, because I still have dy and I still have dx, I integrate again. So let me integrate this constant with respect to x. Then when I integrate dy, because okay, this constant, I can see that I need to integrate again, and when I integrate again, I'll get another constant. Let me call this constant 1 or c1. So if I integrate dy, I'll get that this is equal to y. But now when I integrate sine, it gives me a negative cos 3x. It's supposed to be negative cos 3x over 3. So the 3 will multiply with the 3 in that denominator. So 3 times 3 is 9. Then when we integrate c dx there, we'll get that is equal to c1x plus now c2. Of course, these constants, it's your choice. You can call them a and b, so it's up to you, just to show that it is not the same constant as before. So okay, now I think that this is good enough. This is the general solution. So if another question comes and say find the general solution again, we are still under separable variables. So let's look at this one now. Maybe on this one we will need a little bit of solving. So now we can see that we do have y variables and x variables. So we have x squared y dy dx. So we can start by multiplying both sides by dx so that we can take dx to the other side. So we write this as it is, y squared. When we multiply both sides by dx, the result will be in this way now. So, okay, if we look at our general formula, I said that let's try to make y to be on the left hand side and x to be on the right hand side. So here, let's just rewrite this in this way: y plus x squared y dy is equal to, because we want to make y subject of the formula at the end, then x squared dx. So the previous step and this one, they're exactly the same. It's just that now it's just opposed. We just switch the sides. So we can factor out y in this one on the left hand side. If we factor out y, we find that we have 1 plus x squared dy equals to, we can factor out x on the right hand side. We'll find that it is 1 minus y squared dx. So now we need to separate the variables. The variables of y should be attached on the dy. The variable of x should be attached on dx. So if we divide both sides by, and divide by this, so we do the same. What we do on the left hand side mathematically, we need to do on the right hand side. So we can see that this one cancel here, and then this one cancel here. So this side will be left with y dy over 1 minus y squared equals to x dx over 1 plus x squared. So now we can integrate. We integrate to show that we are integrating. We introduce the integral signs. So we can see that how can we integrate this On the left hand side, we can have this formula here, f prime y over f of y is just going to be ln y. I won't write plus c. We know that when we are integrating, we need plus c. Or let's write it. It's okay. Then this side, integral of f of x. The formula is the same. I just want to show that on the other side we have y variables, and on the other side we have x variables, like that. So this formula says that if in the denominator f of y it's 1 minus y squared, then f prime y, when we differentiate this, we get that is negative 2y. So this side, if we have f of x is equals to 1 plus x squared, when we differentiate with respect to x, we get that this is 2x. Then we are safe to apply this formula if these conditions are satisfied. But we can see that on the numerators, we do not have, on the side of y, we do not have negative 2y, but we only have y only. And on the side of x, we don't have 2x, we only have x, but we can introduce that, which is called compensation. So if we compensate on the side of y with negative 2, y is still there. So because we have introduced negative 2, we must divide by negative 2 or multiply by negative half. We introduce negative 2 and multiply outside the integral by negative half. And then we rewrite our equation like that. And then on the side of x, we introduce the 2, we multiply by positive half. 1 plus x squared. So, okay, now we are safe to use this formula on the side of y. So 1 over 2, it's a constant outside the integral. So we say ln of 1 minus y squared equals to 1 over 2 ln of 1 plus x squared plus c. So, okay, we have used absolute brackets here because we know that we cannot take a natural log of a negative. So this absolute values shows that there are limitations to this natural log. So, but however, we can still use normal brackets if we do want. The answer will still be correct, but this is the most correct mathematically. So here, if I multiply both sides by 2, I will get that I will have negative ln. Let me use normal brackets for now. 1 minus y squared. Then the 2, if I multiply both sides by 2, then the 2 also on the right hand side, it will be cancelled. Then this will be 2c. So, okay, we want to solve the value of y. If we want to find the value of y, we will actually need to raise both sides by exponential. So, but we cannot introduce exponential before we deal with this negative. So this one, we can write it in a positive form. Then it's going to be like this. One plus x squared. Then we can let 2c to be equal to a. Let's just put a here. If we let 2c to be equal to a, now it is okay. We can raise both sides by exponential. E to the power ln 1 minus y square equals to e ln 1 plus x squared. Then we know that this side we need to raise them like this. So that is the correct way of raising them. So if we solve here, we know that if we raise a ln function with e, that function there will, whatever that is inside the ln will remain. So here we are simply going to have 1 plus x squared times e to the power a, because we can see that if we have e to the power x plus y, this is the same as e to the power x times e to the power y. So same base, we know that we add the exponents. So even there, so the one that was raised to the ln will be dropped there. We'll drop what's inside the ln and the ln will be gone. And then the a, we can leave it as it is. So let me remove this for now. So from here, the goal is to just make y subject of the formula. Then we can, I think we can multiply both sides by, because the one that is in the denominator is 1 minus y squared. So we will have 1 is equal to 1 plus x squared times e to the power a times 1. Then we can divide both sides by 1 plus x squared, or let's write it like this: 1 minus y is equal to 1 over 1 plus x squared e to the power a. So the goal is to find, like I've said, is to just make y the subject of the formula. So what can we do from here? So if we're having 1 minus y squared is equal to x squared e to the power a, let me confirm if that is correct. So okay, it's fine like that. We can say negative y squared is equal to 1 plus x squared e to the power a minus 1. So if we make y positive, y squared positive, it's going to be 1 minus 1 plus x squared e to the power a. So we can solve for y now. It's like that. One minus 1 over 1 plus x squared e to the power a. So however, if you want to style it, you can say 1 over e to the power a is equal to b. Call it another constant now. It's going to be y is equal to 1 minus b over 1 plus x squared. Can solve maybe so that we can have a single denominator here. It's going to be 1 plus x squared minus b over 1 plus x squared. So here we have managed to make y subject of the formula. So that was finding a general solution of a differential equation. So let's see what we have next. So I think now we need to look at application of differential equation. So we can look at application of variable separable. So let's look at this word problem here that we are having. The problem says formulate and solve the differential equation that models the verbal statement. So what is the verbal statement? That is number one. There's problem number one. The rate of change of P with respect to T is proportional to 25 minus T. So if we need to formulate, so the rate of change of P, so this is the P over the T. So the rate of change of P with respect to T. So it means that this is the rate of change of P with respect to T is proportional to 25 minus T. So we were able to formulate this word problem, the verbal statement of this problem. So we know that if we want to remove the proportional symbol there, we can introduce a proportional constant, and then normally we use k. So it's k 25 minus t. So okay, we need to apply now our knowledge of separation of variables. But for here, I can see that I only have t. I don't have p variable. K is a constant and 25 is a constant. So I can only write it like this. For now, I will have k times 25 is 25k. And then minus k times minus negative t is actually negative kt. So I can multiply both sides by the t. Then this side I will be left with the p only. Then I will have 25k dt minus kt dt. So now I can integrate here. If I put the integral sign, to show that now I am ready to integrate. The integral of the p is equal to p. The integral of 25k is equal to k 25t minus the integral of kt is equal to k is a constant, then integral of t is going to be t squared over 2 plus c, the constant of integration. Then of course here you can see that we can factor out k on both terms on the right hand side of the equation. So if we have k factored out, we'll have 25t minus t squared over 2. So the way you factorize it, it's up to you. So here it's good enough. If you can leave it there, that is good enough. So let's look at the last problem on application, and then there we'll be concluding our lesson. So the rate of change of v is proportional to v. So here we have a full stop here. So I must begin with capital letter. So when t is 0, v is 20,000. And when t is 4, v is 12,500. What is the value of v when t is 6? So we can see that v is a variable, perhaps is a volume or is a voltage, and t is time. And we know that we are talking about rate of change. So it's something which is changing with time. So the first of all, we need to look at the first statement. The rate of change of v is proportional to v. So the v over the t is proportional to v. So that is the word statement there. So if we introduce the constant, proportionality constant, we'll have dv over the t is equal to kv. So now, okay, we are given the value of v when t is 0, and then the value of t, when we are given also the value of v when t is 4, we want the value of v when t is 6. So how can we do that? So firstly, we will need to integrate. We integrate by separating the variable again. In this case, we'll divide by v and multiply by dt. So we'll have k dt this side. So if we integrate both sides. dv over v, when we integrate that, we find that this is ln v equals to kt plus c. So, okay, with this equation, we can be able to do what the statement says and then enable us to be able to solve everything which is there, which we are supposed to calculate. We want to find the value of v when t is 6. So, but it's going to be easier if we simplify this equation further. So, if we introduce e like we did in one of the examples previously, we'll say e to the power ln v, then it's going to be e to the power kt plus c. So I think another example that another misconception that students make sometimes, they will say e to the power kt plus e to the power c when they introduce the exponential, so of which is not the right way to do so. So you have to do it in this way so that e to the power ln v will get rid of ln. Then this is going to be now e to the power kt times e to the power c. So this is the same because we know that same base we add the exponents. So we can say e to the power c is a. Then we'll have v kt times a, or we can say a e to the power kt. So this is the same, it's still the same. So okay, so they are saying that when t is 0, v is 20,000, we need to find the value of a and the value of k in order to find the value of v at the end. So let's see, we use the first statement when t is 0. For when t is 0 and v is 20,000, what can we find? Let's substitute. We substitute 20,000 in the place of V. Then A remains there. K remains there. We substitute. So we can see that this is going to be 20,000 is equal to A, because e to the power k times 0. K times 0 is 0. E to the power 0 is 1. So that is simply just going to be A. So, okay, when we substitute back now our new equation, it's like this. We replace A with that 20,000. 20,000 E KT. So now we need to find the value of K. So when T is 4, perhaps 4 seconds or 4 minutes or 4 hours or 4 days or 4 years, we don't know the units of that time. And we don't know what is the unit of V as well. So V is just 12,500. So we'll have 12,500 is equal to 20,000 e to the power e to the power 4k. When we substitute 4 in the place of t, we'll get 4k there at the top. So, okay, from now we can divide both sides by, what is this? This is 20,000. It's not 2,000. We divide by 20,000 both sides. Divide by 20,000 both sides. So we can see here it's gone. And then this value leads to 5/8 e to the power 4k. Then we will introduce ln. Ln 5/8 is equals to ln of e to the power 4k. So, okay. So because we have introduced the ln, we can actually bring down that exponent. So this is going to be ln 5/8. It's going to be 4k ln e. It's just 4k ln e. Ln e is 1, so we just ignore it. It's just going to be 4k at the end. And then when we solve, we say k is equals to ln 5/8 divided by 4. We get that k is equal to negative 0.1175. So we have now found the value of k into our equation. So let's work on the same page. Let's just work on the same page. Let's get rid of this one here. So we still have that equation. It's 20,000 e to the power. The value of k is what? Is negative 0.1175 t. So now when t is 6, what is the value of v? That is what the question was asking. V is equal to 20,000. We substitute the value of t there. We have negative 0.1175. We introduce 6 in the place of t. Then when we punch this in the calculator, we'll find that this is equal to 9,882.1 715. So this is the last answer. This is the final answer to this problem. So thank you for watching. Today we will end here. We will continue with differential equations on the upcoming lessons. Thank you for watching. Please like this video and do comment. And please subscribe if you haven't subscribed to the channel yet. Thank you.